temperature. So once I hit 30 degrees Celsius on the LN2 container, you can see I could achieve a maximum frequency of 5600 megahertz, and then I could go up to 6.1 gigahertz at minus 60 degrees Celsius. You can see there's a 500 megahertz scaling from plus 30 to minus 60, which is really impressive. And we can also see from here, and what we can also translate from there is if we go from a 30 degree to a 20 degree Celsius water block, we can increase the core speed by 50 megahertz, which is actually quite impressive. What is even more impressive is that if we go from plus 50 to minus 60 degrees Celsius, we lower the power consumption from about 250 to 175 watts. So power consumption by 75 watts by lowering the temperature. So a massive cooling unit, of course, can be worth it if you want to overclock your 9900K to the edge. A custom water cooling loop is still the way to go. So after we did the basic testing, I sat down with Alex from Romania and we wanted to compare the 8700K to the 9900K extreme overclocking results. So back then, when we did the 8700K extreme overclocking, we pushed the CPU to 6.8 GHz at 1.75 volt, which achieved a Cinebench R15 score of 2253 points, and in multi-threading and a single-threaded result of 299 points, and a maximum validation of 7312 megahertz. Now the 9900K has exactly the same single core speed, so the single threaded performance at 6.8 GHz in R15 is the same at 299 points, while the multi-threading speed increases drastically to 2913 points, which was kind of expected by adding 2 more cores and a bit more cache. Validation also increased on the 9900K, even though we have 2 additional cores, so we could increase the validation to 7484 MHz, which was the highest I could achieve using liquid nitrogen. And I think that's mainly the result of the CPU being soldered, but of course it could also be that the CPU was just a really good sample. We also checked the power consumption in Cinebench R15 multi-threading, which was 380 watt peak, roughly at 6.9 GHz, and the score in Cinebench R15 was almost 3000 points. In LN2 overclocking is not much higher. It's just that the low temperatures really help to decrease the power consumption, so we almost end up at the same power consumption in the end as using massive ambient overclocking. So after 3 days of preparation and pre-testing, we brought out the big toys. So we ordered 2 tanks of liquid helium, 100 liter each, and 1 tank I think is about 3000 USD. So it's really expensive, so we had to make sure that everything is really well prepared, that we know exactly which CPU can run at which temperature and at which voltage setting and in which benchmark. The first setup was my setup, which was meant for CPU-Z validation. So we just wanted to see how high can we push the CPU with all cores and hyper-threading active. Basically just ramp up the clocks while also keeping control of temperature and voltage. Voltage was about 2 volt for the validation itself, and the temperature was about minus 220 to minus 225 degrees Celsius. If we went lower in temperature, lower than minus 225 degrees Celsius, the USB controller wouldn't work anymore, so I wouldn't have control over keyboard and mouse. That's why we had to move over. While we were running with liquid helium, we had to move over to a PS2 keyboard. That's also the reason, or one of the reasons, why those extreme overclocking mainboards like the Maximus 11 Gene still have a PS2 port. Because in some conditions, especially if we use Windows XP, we still need PS2. But after roughly 10 minutes, we achieved a maximum clock of 7613 megahertz, which is almost 300 more than on the 8700K, and I think it's the fastest Intel Core series CPU ever. Afterwards, we moved over to Roberto's rig, which was meant for PFast, and PFast is a single-threaded benchmark, so we can disable some cores in the BIOS to lower the power consumption, which essentially allows us to run a little bit higher clocks. We were using 3 cores active on the CPU, and Roberto pushed the CPU to 7.5 GHz across the 3 cores, and then he ran the PyFast benchmark, achieved a score of 8.39 seconds, which is also a new world record in PFast. In the end, we moved over to Alex's system, which was prepared for Cinebench R15, which equals some heavy multi-threading load, and pushing the CPU to 7 GHz at 1.8 volt is extremely heavy, and it produces so much power that even with liquid helium, it's very hard